Hello everyone. Today, I'm going to show you an incredible trick, transforming this old, seemingly useless refrigerator compressor into a surprisingly powerful welding machine. Typically, a compressor unit, once decommissioned, is considered scrap. I'm going to begin by applying some WD-40 around the compressor's seam and cleaning it thoroughly. This helps loosen any rust or grime, making the next steps much easier. After that, I'll remove the small electrical box located on the side. With the box off, I'm now ready to open up the main shell. Using an angle grinder, I'll meticulously cut along the seam that runs around the compressor's body. This creates a clean opening, allowing me access to the internal motor. This step generates a lot of sparks, so always make sure to wear appropriate safety gear. After the initial cut, I'll use a screwdriver to carefully pry open the casing, revealing the internal components. With the casing open, you can see the compressor motor inside. It's surrounded by some oil, which is typical for these units. Now, with the motor removed, I'll start by cutting the wires that connect the internal components. This allows me to separate the main motor unit from the rest of the housing. This copper coil is the heart of our project. With the motor assembly isolated, I proceed to disassemble its housing, removing the fastening bolts and separating the outer shell. The primary objective here is to access and extract the laminated steel core and its copper windings, which will serve as a foundation for our induction transformer. Each component is carefully handled to prevent deformation or damage. This meticulous approach ensures the integrity of the core material for optimal performance. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. I meticulously stripped the insulation from the wire ends of the existing windings. The laminated steel core and copper windings are now isolated. Now that I have the motor assembly, I need to strip away some of the outer insulation from the copper coil wires. I'm using a utility knife to carefully score and peel back the plastic, exposing the bare copper. This is crucial for making good electrical connections later. Subsequently, 2 sets of new insulated wires, one red and one yellow, are prepared. Next, I'm preparing the wiring for our primary circuit. I'm stripping the ends of some red and yellow electrical wires, then twisting them securely onto the existing coil connections. This creates a strong electrical and mechanical bond. After twisting, I'm insulating each connection carefully with red electrical tape. This is super important for safety, preventing any short circuits once power is applied. You want solid connections for optimal current flow, especially in a high power application like welding. I'll repeat this process for the other side of the coil, attaching lengths of yellow electrical wire, stripping, twisting, and then securely taping them with red electrical tape. The insulation is key here for both functionality and safety. Next, I prepare an orange male electrical plug. This involves carefully disassembling the plug housing to access its internal terminals. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. The stripped ends of the red and yellow wires from our modified transformer are then securely attached to the respective prongs of the plug. Each connection is tightened using a screwdriver to ensure optimal electrical contact and prevent loose connections, which could lead to arcing or overheating. The plug housing is then reassembled, securely encasing the wire connections, thereby completing the primary side's electrical interface. For the secondary coil of our welder, I select a segment of PVC pipe. I'll measure and cut a suitable length of pipe. I'll clean any burrs from the PVC pipe with a knife. Then I'll drill 2 small holes through the side of the PVC pipe. This hole will be used later to secure our components. The edges of the pipe and the drilled hole are carefully deburred and cleaned to prevent any abrasion to the wire insulation during the winding process. Subsequently, I begin winding a length of red electrical wire around the PVC pipe. The wire is systematically threaded to the pre-drilled hole and tightly wound around the pipe's exterior. This process creates a solenoid, which will function as the secondary coil for our induction welding apparatus. The turns are kept uniform to maximize electromagnetic coupling and efficiency, ensuring the desired output current for welding applications. Once fully wrapped, I'll cut the wire and make sure it's secure. Now, let's bring our 2 coils together. I'm inserting the PVC secondary coil into the center of the primary coil, ensuring a snug fit. This close proximity is essential for electromagnetic induction. To keep it all securely in place, I'm using 2 zip ties to firmly fasten the PVC pipe within the transformer. Once secured, I'll trim the excess from the zip ties. Next, I'm connecting the wires from our secondary coil to a pair of heavy-duty alligator clips. These clips will provide the electrical contacts for welding. I'll strip the ends of the wires, insert them into the clips, and crimp them securely. Now, to prepare the welding end, I'm taking the specialized welding electrode holder. I stripped the outer insulation of the remaining red wire and secured it securely with the special soldering iron. The stripped wire ends are then firmly attached to the copper jaws using screws, ensuring robust electrical contact. The welding clamp is then reassembled, securing all internal connections and the handle. This comprehensive preparation ensures reliable and safe current transfer to the welding electrodes. After securing everything, I'll test my main power source. I have an extension cord here, and first, I'll plug in an LED bulb to make sure it's live and working. Perfect. The light comes on. Now, I'll use a multimeter to check for continuity across the extension cord's outlets. This verifies that our power source is fully functional and ready. And now, for the moment of truth. I'm plugging the transformer's modified plug into the live extension cord. I took the soldering iron and attached it to the soldering clamp. Then I attached the alligator clip to the iron bar that needed to be soldered to complete the circuit. See that bright flash in the molten metal? Upon activation, the concentrated current from the secondary coil generates a high-intensity arc, causing localized melting and fusion of the metals, thereby demonstrating the successful conversion of compressor into a highly effective welding device. This successful demonstration underscores the viability of repurposing industrial components for specialized applications. Thank you for watching, and I'll see you in the next one.